Right, today we're looking at the product of burning metals in air, and you should have just seen the videos where you just burn some. If you have a look at those videos, you can see that some of them react a lot better, but generally what we get is reactions. We can usually see something happening, and you can see what the products are. It's just whatever the metal is, plus the word oxide afterwards. So if we just very quickly look at some word equations. So I've coloured the magnesium in red to show it's a metal in this thing here, so I can make that a metal there. That's the metal, and it's reacting with oxygen. When it reacts with that, it just simply becomes metal oxide. That's what we call a metal oxide. You've got magnesium and oxygen makes magnesium oxide, and it's the same for all of these. So calcium and oxygen, yep, we can do that. Calcium oxide, I can colour that red just to show it's the metal. Iron oxide, iron and oxygen, they go together, makes iron oxide. Now I've just flipped these round here. You can see that the red one is the metal and it's reacting with oxygen, and there we are. Okay, so it's the other way around, but it's still got the name the same way. It's still sodium oxide. It's not oxysodiide or something, just because these have been swapped around. It makes no odds really there. Well, every time something burns, it's always reacting with oxygen. That's what we're doing all the time, metals plus oxygen, and makes aluminium oxide. If we're ending up with potassium oxide, well, we must be starting off with potassium and oxygen, one way around or the other, potassium being the metal. And then the last one there, I've got iron oxide. We've had that one before, but we're looking at the other way around. If we're ending up with iron oxide, the two elements that must join together would be the iron and the oxygen. Now then, let's just have a look at what would happen if we tried to balance those. So I've got the same things here. Ooh, looks quite nasty. There's lots of stuff there, but it's really just the same, showing the same thing. Magnesium and oxygen makes magnesium oxide. Now, if you've got to balance these, this is telling you that however many atoms of magnesium you start with react with a load of oxygen atoms and they make magnesium oxide, and you must have the same amount you start with. Now the thing that messes it up really is oxygen always goes round as a pair. It's what we call diatomic. There's two of them. They go round in twos. So this is currently showing us that one magnesium atom reacts with two oxygen atoms to make one magnesium atom joined to one oxygen atom. Now that can't be the case. It cannot be the case because there was two to start with. However, we can't just stick a 2 here, because actually if you look at the structure of magnesium oxide, there isn't a 2 there. That's not what you get. It is in fact one magnesium joined to one oxygen. That cannot be changed. So if we look through these, what do we need to do? Well, we've got 2 oxygens here, so I'm going to stick a 2 here. Now that means we have two bits of magnesium joined to oxygen. So we've got 2 oxygens on the left, and we've now got 2 oxygens on the right. But we've kind of messed it up now, because we've got 2 magnesium atoms and we didn't have them. So that means at the start we must have had 2 of these. We must have had 2 magnesium atoms. There must have been. And that's what we call balancing. Let's try the next one with calcium oxide. We've got 1 calcium meeting 2 oxygens, and it's making calcium oxide. Very similar to the one before. We had 2 oxygens, now we've got 1, so I'm going to stick a 2 here. I'm going to stick a 2 there just so that we know we've got 2, but now look, we've messed it up. We've got 2 calciums, so let's put 2 over here. And I think that's right. I could, if I wanted to, stick a number 1 in there saying 1 times 2, but we just generally don't bother. If there's 1 of them, we just leave it blank. Okay, now iron plus oxygen, again, got to be diatomic oxygen. There's got to be 2 of them. But weirdly, I'm not going into this today, but we can see that we have iron oxide, Fe being the symbol for iron. When they join together, there's 2 of these and there's 3 of those. 2 iron and 3 oxygen. Okay, so it's good if you know your times table. 2 and 3, they're both factors of 6. That's a good thing to know. 2 and 3 are both factors of 6, because what I would do to balance that is I have got, if I stick a 3 in front of the oxygen, I've I've now got 6 oxygen, and if I stick a 2 in front of the iron oxide, I've got 2 times 3 makes 6 oxygen. Well, that's all good. But now I've got 2 times 2 iron. 2 times 2 iron, that makes 4, so I'd stick a 4 in front here. So we've got 4 iron and 4 iron on the right, 2 times 2, and we've got 3 times 2 is 6 oxygen, and we've got 2 times 3 oxygen, yeah, 6. That was a tough one. Remember, I'm not telling you why that's Fe2O3, you've just got to accept that's the way it is in nature. Similarly, sodium oxide is Na2O in nature, we can't change that. But that's a fairly easy one to balance compared to the last one. We've got 1 sodium here and we've got 2 there, so I suggest, let's stick a, oh, we've only got 1 oxygen there and we've got 2 there. Okay, so what I'm going to do is I'm going to stick a 2 here. The 2 there means 2 times all of this. We've now got 4 oxygen atoms. Well, I can sort that 4 oxygen atoms out by putting a 2 here in front of the oxygen. 2 times 2 is 4. And, well, there's 4 sodiums, so if I stick a 4 here, it's all balanced. Remember, what we're doing is we're just trying to show what it is like actually in nature, what is actually happening. I know it seems like a right faff, but this is explaining exactly what is happening. Right, ooh, this is like the iron one, isn't it? This is like the one with iron, and we just got to accept Al2O3. We will learn that at some point. So, let's go for, let's sort the oxygens. Oh, remember, 2 times 3 is 6. Good thing to remember. So, let's put a 3 in front of this one, 3 in front of the oxygen, 6 oxygens, and we've got 3 here, so we'll do a 2 there. So we've got 6 oxygens on the left, and we have got 2 times 3 oxygens on the right, which is 6. But we've now got 4 aluminiums, so let's stick a 4 there. And the last one, potassium. Right, let's go for this. We have got, oh dear. Let's start with the oxygens. Doesn't matter where you start, but we'll start with that. We've got 2 oxygens here, and we've got 1 there, so I'm going to stick a 2 in front of this. So if I stick a 2 in front of that, 2 oxygens, we're all good. I can stick a 1 there, but we're not going to bother. But we've now got 4 potassiums, so I'm going to stick a 4 there. So boys, you've just seen a few things. We've seen when a metal reacts with some sort of oxide, when a metal reacts with oxygen, you get an oxide. You can work out the equations quite simply. Metal plus oxygen makes the metal oxide. And we can also balance them. If you know what you start with, if you know the final product, if you know the final thing is Fe2O3, or if you know it's CaO or whatever, and you remember that oxygen is O2, oxygen is always O2, then you can work those ones through. Alright? Cheers, thank you.